backgrounds and where they're from. And I saw someone say in the chat that air finally beat out water for where most people are coming from. And that's probably because Bob dragged all of us from Airshed Sciences to attend the talk. So I think that's where a lot of the air folks are coming from. Anyways, yeah, I'm really happy to be giving this talk because I really enjoy interdisciplinary conversations. So I'm happy to see that there's people from water and biodiversity. So today I'll be talking to you about how our team is working to address gaps in wildfire smoke monitoring through citizen science. So the purpose of this presentation is kind of threefold. It's first to raise awareness of the project and to tell all of you about the different tools and websites available that can help you understand air quality and its implications for health. It's also to facilitate collaboration within the citizen science community. And lastly, it's also a great opportunity for me to learn more about citizen science practices, because my background is chemistry, so it's not an area I have a lot of exposure to. So I'm also really looking forward to the discussion at the end. So this work was done by our Airshed Sciences team, so I'm just kind of the point person for the project, and I didn't bother listing everyone's name here. But yeah, there's contribution from many others, and I'll just sort of highlight people as I go through the presentation. So here's just a quick outline. So not everyone in the audience is overly familiar with air quality, so I'm going to make sure we're all on the same page and just give some background on what the air quality implications of wildfire smoke are and how air quality is traditionally monitored in the province. And that'll really set the stage for the opportunity for citizen science to help fill some of those air monitoring gaps that have been left by traditional air monitoring. So yeah, I'll start talking about wildfire smoke, and for anyone who's been living in Alberta for a while, this shouldn't be a surprise, and certainly doesn't take an atmospheric scientist to tell you that smoke impacts air quality. So the image on the left is actually from a satellite. You can see the smoke from space. So this is from the 2016 Horse River or Fort McMurray wildfire. You can see just the vast area that this wildfire is covering, and you can even see the smoke from space. Fort McMurray is kind of below this cloud in the center there. And then the image on the right is, it's not a screenshot from The Last of Us, but it's from a couple summers ago when a wildfire smoke event hit Edmonton. So yeah, I mean, for someone such as myself who didn't grow up in Alberta, it sort of hit me the first summer I was here, how ubiquitous wildfire smoke is. I remember my first summer here, I stepped outside and smelled what I thought was a barbecue, and I thought my neighbor was barbecuing something, but I walked halfway down the street and the smell was still there. And I thought, oh, this is wildfire smoke. It really was quite something. So for those of you who might be from outside of Alberta and haven't, I guess, appreciated the impacts of wildfire smoke, it really is a big issue here most summers. And the issue is getting worse, unfortunately. So as a result of climate change and generally increasing temperatures, there's a whole ton of research that's been done that has shown that the risk of very large fires is increasing due to climate change. And this is certainly reflected in this data from the National Forestry database that my colleague Travis DeCarrick in the group compiled, so I could make these nice figures. So on the left is just showing the area burned in Alberta for every year since 1990. And then on the right, it's the total number of wildfires in Alberta every year. So yeah, you can see there's a lot of year-to-year variability, but certainly, in more recent years, we're getting summers that are more punctuated with these very large fires where you get, upwards of 1 million hectares of area burned, which is a lot. And in terms of what's emitted to the air from wildfires, well, pretty much everything. Almost every single air pollutant that you can think of is emitted from wildfires. But the amount and composition of the emissions will depend a lot on the type of fuel. For example, if it's a peatland burning, you're going to get different emissions than if it's a big coniferous forest burning. The amount of fuel also has an impact, and so do the burning conditions. A smoldering fire near the surface is going to keep the emissions closer to the surface, whereas a fire that's undergoing really open flaming and open combustion will kick air pollutants, aloft and even sometimes into the stratosphere. So I'm going to broadly, for this talk, fit the air pollutants into two categories based on phase. So the first is gases. So I just listed some of them here, and everyone on the line is going to be familiar with things like carbon dioxide, carbon monoxide, mercury. And then the second sort of category are solid and liquid pollutants that are suspended in the atmosphere. So we call these particles. and they come in all sorts of different shapes and sizes and chemical composition. So I've used my limited artistic abilities to sort of try and portray that here with different sizes and shapes and colors of particles. And of course, the air quality impacts from the wildfire smoke will depend not only on the emissions themselves, but also the distance between where the emissions are occurring and the community or receptor. So typically, the further the distance, the more chance the smoke has had to mix with clean air, so the concentrations will go down. But it also is impacted by meteorology, like wind speed and direction, and also sunlight, because a lot of these pollutants can react as they transport through the atmosphere and create new pollutants or transfer between gas phase and particle phase. So, you know, wildfires are really dynamic in terms of emissions and severity, but also in sort of the soup of pollutants that they emit. So the rest of this talk is going to focus in on the particles or particulate matter. So when, you know, us in air quality talk about particulate matter, one of the most important factors is the size of the particle. And the reason that is because the smaller particles that are, you know, typically smaller than 2.5 micrometers in diameter, called PM 2.5, are so small that they can get deep inside your lungs and cause cardiovascular and respiratory issues. Whereas the larger particles can get filtered out by things like your nose hairs, or deposit out much faster in the atmosphere. So yeah, it's these smaller particles under 2.5 micrometers that are really detrimental to health, and they also stay in the atmosphere for a lot longer. So it can be hard to sort of wrap your mind around what a micrometer is. It's 1/1,000,000th of a meter, and there's this nice figure from the U.S. Environmental Protection Agency, the U.S. EPA, not to be confused with us, the Alberta EPA, that shows the size of PM 2.5 particle here, like a little pink circle, in relation to the size of a human hair. And then also shown here is the size of a fine grain of sand that you would find on a beach. So, you know, an individual particle is invisible to the naked eye, but if there's a ton of them in the atmosphere, you get this haze and it really deteriorates visibility. So PM 2.5 is important because it's what's called a non-threshold pollutant. So what that means is PM 2.5 can cause adverse health effects at any level, even really small concentrations. But nonetheless, pretty much every jurisdiction around the world, including Alberta, has developed health-based guidelines and objectives for reporting and managing air quality. So for example, in Alberta, 24-hour average for PM 2.5 concentrations in the air is 29 micrograms per meter cubed, and the 1-hour average guideline is 80 micrograms per meter cubed. And again, since not everyone on the line is from an air background, I'll try and parse out what that actually means. So if you think of a single poppy seed, that weighs about 300 micrograms, and a microgram is 1/1,000,000th of a gram. So if you take 1/10 of a poppy seed and put it in 1 meter cubed of air, which is about the size of an oven, I guess, then that's right around the 24-hour average objective for Alberta, which doesn't seem like a lot, but it really makes a large impact for health, especially with those with pre-existing conditions like asthma. So yeah, I mean, it might not seem like a lot, but it really does have a big impact on air quality and health. And how we typically report on PM 2.5 concentrations is through a figure like this. So this is taken from a 2018 paper by Matt Landis that shows the 1-hour average PM 2.5 concentrations in Fort McMurray during the 2016 Horse River wildfire. So on the y-axis on the left is the PM 2.5 concentrations in the units of micrograms per meter cubed of air. And then on the x-axis is just time, starting from sort of the last week of April to the second week of June. So if you recall, the fire started on May 1st, and you can see that Matt here on this figure has shaded the times impacted by smoke in gray. And you can see when smoke is impacting this air quality monitoring station, the concentrations go, you know, ridiculously high, like, you know, upwards of 3,000 micrograms per meter cubed. But it really is dynamic. You know, if the wind shifts, you can go from, you know, like 1,200 micrograms per meter cubed to something that's relatively clean. So, you know, this can be one challenge in measuring PM 2.5 because it can be very dynamic depending on meteorological conditions. So, you know, micrograms per meter cube doesn't mean a whole lot to the average person or the general public. So what air quality practitioners have done is created this really useful communication tool, which most or all of you may be familiar with, called the Air Quality Health Index. So this groups, it's a scale from 1 to 10 plus that sort of groups the different numbers into health risk. And there's associated messaging with each category, from low risk to very high risk. So in Alberta, AQHI is reported in real time every hour in 39 communities. And it's calculated primarily from concentrations of PM2.5, which I've talked about, as well as ozone and nitrogen dioxide, which are gaseous pollutants that are associated with wildfire smoke. But typically it's the PM2.5 in wildfire smoke that drives poor air quality. And AQHI in Alberta is forecast twice a day, so people can have a sense of what the expected AQHI value will be and can plan their activities accordingly. And just for reference, the high or very high risk category corresponds to a 1 hour PM2.5 of about 80 micrograms per meter cubed, assuming that there isn't much ozone or nitrogen dioxide around. So there's this really neat tool that the government of Alberta has developed that visualizes the Air Quality Health Index. So what I'm going to do here is actually go to this website and just give you a little demo, because this is just a static screenshot. So hopefully you can see this today, and I'll just refresh it so we have the most current data. So if you go to this website, it brings up this map and it shows you what the Air Quality Health Index is in all the communities that report it across Alberta. So it's really useful for the public to get a snapshot of what air quality is like in Alberta. And it groups the AQHI by communities here, so you saw most people were in the North Saskatchewan region. So in Edmonton, AQHI is forecasted to be 3 for the rest of the day. You can go to this tab to get a detailed forecast, and yeah, Edmonton's pretty consistent here, 3 forecasted for the rest of the day. But larger communities like Edmonton and Calgary have multiple stations, so you can actually go to the stations tab and see what individual stations in Edmonton are reporting, because the AQHI just takes the average value from all the stations. So for example, if you're in downtown Edmonton right now, the closest station is Macaulay here, and that's at 5.8 micrograms per meter cubed. And if you're towards the south, the station's at 4.7 micrograms per meter cubed. You can also go backwards in time. You can select different pollutants. You can see what something like carbon monoxide is doing. You can also query and download the data as well, either by AQHI or parameter or by station. So I obviously check this pretty frequently as part of my work, but as a citizen, I will also check it in. Do I go for a run outside later today, or do I stay inside and take it easy? So yeah, I recommend checking out this tool if you're not familiar with it. So another tool that the government's used to report and communicate air quality are special air quality statements. So this is joint by the federal and provincial governments, and we work together to assess and communicate air quality events. So what happens is if one of these stations that I showed you on the previous map gets concentrations of whatever pollutant above a certain threshold, we'll get an automatic notification, which people from our team and the federal government will assess and verify that the data are indeed real, and provide some messaging around what the cause is. And if it's wildfire smoke, it's usually pretty obvious. And then a special air quality statement will be issued, which looks a little something like this. So you can see on March 20th of this year, there was a stagnant weather pattern causing pollutants to build up near the surface, leading to poor air quality. And if you download Environment and Climate Change Canada's WeatherCan app, you can get these weather and air quality alerts automatically. So again, this is another really useful tool that if you're a concerned citizen about air quality, I recommend downloading the app. And then one last tool that I think is worth highlighting is something that I actually just learned about last week on a totally unrelated call. It's the Alberta Environment Public Health Information Network, or AEPA. So this is a joint collaboration between Alberta Health and the University of Alberta. And it's great because it provides user-friendly and interactive presentations on various types of environmental monitoring data. So I'll just pop out of the slideshow and take you to the AEPA website. So for those of you who don't come from an air background, they also have environmental health data related to water, food, biomonitoring, and I haven't checked those tabs, so don't ask me any questions on them. But for air, they have a link to the Air Quality Health Index page that I just showed you, and this really neat one that summarizes special air quality statements throughout the province and has some links to the WeatherCan app and some information on the AQHI. So this particular webpage on special air quality statements isn't updated in real time, but I think it's really neat because what I'm showing you here is it shows all the special air quality statements issued across the province since 2014. So for example, in 2014, there were 18 special air quality statements issued, and then in 2021, there were 164. And you can zoom in on the various region, and if I hover my cursor over in the Fort McMurray, Fort McKay area, you can actually see when throughout the year the special air quality statements were issued and how long each one lasted. And just to hammer home the point of how important smoke is for detrimental air quality, you can see that out of all these special air quality statements issued, 729 of them, or the vast majority of them, were related to smoke. So again, wildfire smoke is a very significant issue in Alberta with respect to air quality. Okay, so that's a crash course on smoke and why it's important, and the different tools that are at the public's disposal for looking at sort of the high-level picture of air quality and the impacts from smoke. And before I dive into the citizen science, I think it's important to give context on how air quality is traditionally monitored, because again, most of you or some of you on the line will not be familiar. So what I'm showing here is a typical air monitoring station from the outside on the left and from the inside on the right. So the photo on the left is the Edmonton East Station. So it's by Refinery Row in Edmonton, and I think the station itself is older than me. So I believe the shelter is getting replaced soon. And yeah, on the outside, you can see some air quality instrumentation on the roof, and then there's a couple of inlets that pull air from outside into the trailer. And then here's a photo from the Wood Buffalo Environmental Association, showing the inside of a typical air monitoring station. And yeah, you can see these sort of different boxes here, each of which is a different air monitoring instrument, which measures different pollutants really precisely and on a minute time scale, so really quickly. So these are kind of like the Rolls Royce of air monitoring instruments. And they're pretty sensitive to temperature, so they need to be inside a trailer. You need space in the trailer because these need to be calibrated every month by a trained technician who spreads out with their equipment to calibrate the instruments. So yeah, all of this, all told, putting in a new station costs around $300,000, and then each of these instruments costs tens of thousands or low hundreds of thousands of dollars. So it does take quite a bit of resources to set up one of these continuous or permanent or traditional air monitoring stations. But these are the type of data that are used to generate the AQHI map that I showed you a couple slides ago. So this is what traditional air monitoring looks like. So who actually does the air monitoring in Alberta? Alberta is somewhat unique among provinces and territories because unlike some other provinces and territories where it's just the provincial government doing all of the air monitoring, evaluation, and reporting, Alberta's air monitoring is conducted using what we call a distributed model. So there's multiple organizations that have a shared responsibility for air quality monitoring, evaluation, and reporting. So of those, the stations I just showed you on the previous slide, a handful of them are actually operated directly by environmentally protected areas. And it's typically our responsibility to interpret and analyze the data and report on it through things like status of air quality reports. Environment and Climate Change Canada also uses some of the data to report through their National Air Pollutant Surveillance Program. But the vast majority of ambient air monitoring done in the province is done by what we call airshed organizations. So I believe there are 9 of them in the province. And airshed organizations are community-based, not-for-profit, multi-stakeholder groups that monitor and report on air quality data within a specific region. And they do great work. And since they're multi-stakeholder, it sort of brings everyone to the table as well. So we can collectively tackle air quality issues and monitor and manage air quality as needed. And then industry also directly does some air quality monitoring, but that's typically on site or near fence line and is used for compliance purposes to make sure that environmental parameters and their approval conditions are within limits. So here's a map showing where all of these continuous or traditional air monitoring stations are. I apologize if this map is a little bit outdated. I think it's from about a year ago. But all told, there was over 70 continuous air monitoring stations. So yeah, this work was led by Yeni Akvalu and Kristen Adams from our group to classify each of the air monitoring stations for intended use. And so that's why there's different marker colors here on this map. But you can see just by looking at this, the air monitoring stations are concentrated in larger population centers like Edmonton and Calgary, and also near industry, right? Like up in the Athabasca oil sands region and Peace River and Cold Lake oil sands region, and also in sort of west central Alberta, where there's things like coal mining and also some former coal-fired power plants or electrical generation units. And it's important to recognize that not all stations monitor the same parameters. And it also doesn't take an atmospheric scientist to tell you that there's large regions of the province that don't have traditional air monitoring. These $300,000 stations. I should also mention that these gray or green shaded regions you see are the airshed boundaries. So monitoring is also typically concentrated within airshed organization or airshed regions. So in addition to this permanent, continuous, or traditional air monitoring, Environment Protected Areas also has the capacity and mandate to monitor air quality during emergencies. And there's a couple tools we have at our disposal to do this. So the first is the Mobile Air Monitoring Lab, which is really neat. It's basically like an RV that's been kitted out on the inside with air monitoring instrumentation. So you can think of it like a traditional air monitoring station on wheels. So it can drive around and respond to things like wildfires or industrial upsets or emergencies. And then there's a slightly less intricate or interesting EBAM particulate matter monitor. So these costs, I think, like $10,000 or several tens of thousands of dollars. So a technician has to go out, deploy it, and it can measure different sizes of particulate matter, as well as wind and temperature and relative humidity. So you can just set up this tripod kind of wherever. Some of them have solar panels so that they can work without line power. And they can also be fit with a cellular modem, so the government can see the data in near real time. But again, these are great, but they're typically reactive or deployed reactively. So again, it doesn't take an atmospheric scientist to tell you that there's these large spatial gaps in traditional air quality monitoring, and the reactive monitoring is great, but if wildfire smoke is inundating large parts of the province, I think it'd be useful to know sort of ahead of time or as it's happening what the levels are in as many communities as possible. So our team led an assessment to identify which areas are most susceptible and would be highest priority for deploying proactive smoke monitoring. In order to make sure we were using our resources most efficiently. So one of the questions we set out to answer last year or 2 years ago was, well, where does the smoke occur? We know everywhere in the province gets hit by smoke, but do some regions get hit more than others? So work led by Cassie Brown, who's an atmospheric scientist with the group. Through our standard air quality reporting, Cassie and her team has to figure out which stations are impacted by smoke each year. So using data that she had already sort of collated, we were able to tabulate the average number of smoke days identified in each region. So these actually correspond to the regions from that were part of the questionnaire or quiz at the beginning that Krista led. Peace, Lower Athabasca, Upper Athabasca, North Sask, South Sask, and Red Deer. So what we did is for 4 years, 2015 to 2018, we just tallied up the number of smoke days identified at each station in each region. And then this first column here with the bolded numbers is just the average number of smoke days in that region between 2015 and 18. So based on this, it looks like Lower Athabasca is most frequently impacted, or the most number of smoke days. And then, Peace and North Sask and Red Deer, have about a week and a half on average number of smoke days per year. But if you look across any of these rows, there's a lot of variability, right? Like if you look at Athabasca in 2016, there just happened to be no smoke days that were picked up by the traditional air monitoring stations. But the following year, there was over 3 weeks. So there is significant year-to-year variability in smoke impacts. And we also wanted to get an idea of, on these smoky days, how much particulate matter is there. So the 24-hour median for these smoke days was between 30 and 40 micrograms per meter cubed. But then some days were upwards of like 200 micrograms per meter cubed. So just to refresh your memory, the 24-hour air quality objective in Alberta is 29 micrograms per meter cubed. So even on the less smoky days, there was still enough PM to start to be concerned about. We also had another tool at our disposal to figure out where smoke most commonly occurs. So this is work that was led by Kristen Adams, who is now in Environment Canada, but was in our group at the time. So she worked with the Blue Sky Smoke Forecast Modeling team. So Blue Sky is a really neat collaboration between Alberta and British Columbia that forecasts or models smoke using forest fire information and weather forecasts. So from satellites, we can figure out sort of where the fires are and how intense they are. And then using weather forecasts, we can estimate or model how that smoke is going to be transported a couple days forward in time. So using model runs that had already occurred and sort of stored, Kristen was able to look at the average number of days across the province spatially that were impacted by smoke. So 2015, 2016, 2017. So each of these different panels is a different year, and yellow means more smoke days, upwards of 30 smoke days, and dark blue would mean 0 smoke days in that particular part of the province. So it's interesting, again, this year-to-year variability. In 2015, it was the southern part of the province that was hit really hard, whereas in 2016, it was the northern part, and then 2018 was a pretty quiet year for smoke. But this is generally consistent with the previous slide I showed you. But one neat thing we're able to do here is Kristen was able to split up the data by month. So on the left is May, June, and July, and on the right is August and September. So this pretty clearly shows that smoke is more prevalent in the north in May, June, July, but then later in the summer, there's typically less smoke far in the north, and then much more smoke in the far south. So the last sort of piece of evidence we use to figure out where the smoke is occurring most frequently are satellite data. So there are various satellites orbiting the Earth that have instruments that look down at the Earth and can measure air quality over large regions. So again, this is work done by Kristen Adams, who was a resident satellite expert. So what Kristen did is she took data from a 15-year period, 2005 to 2019. And it's a little bit hard to see here, but this is the outline of Alberta. And then on the right of this image or figure is the border with Saskatchewan. And on the top is the border with the Northwest Territories. And it's showing aerosol absorbing index. For the purpose of the talk, it doesn't really matter what it is, but you just need to know it's a proxy for smoke particles. So the more red or yellow the pixels are on this image, the more smoke there was on average during that 15-year period. So again, this is like a third line of evidence that shows that smoke is generally most prevalent in the far north and the far south. And these data were also consistent temporally with the air monitoring and the model data. So using that information, we were able to pretty confidently say that the most susceptible areas are northern and southwestern Alberta. So then we wanted to line that up with where air monitoring is currently taking place with communities that don't have air monitoring. So I leveraged some work done by Kristen and Yaney that they did through our 5-year monitoring, evaluation, and reporting plan, where they were looking for gaps across the entire province. So what Yaney did is she compiled the information about each community in Alberta, the location and population, and said, does it have a long-term traditional monitoring station? And if it did, then it's not a gap, it has air monitoring already. But most communities don't, so they would follow this no path. And then Yaney compiled information on population, distance to nearest station, potential industry impact, and ambient concentrations, and then came up with a subjective numerical rank for communities that should be prioritized for air monitoring. So I just adjusted this analysis by only considering population and distance to nearest station, and then it spits out this numerical rank for each community, and then you can just see which communities rank highest and sort of use that to guide where we should focus our resources initially. So based on that process, here's what the original list came up with. So Lloydminster, High Level, and Brooks topped the list. And so each of these 10 communities from the original list I've put here on a Google Maps with a red marker. And I've also put a blue marker, air monitoring that occurs in other jurisdictions like British Columbia and Northwest Territories that's right on the border that we could leverage. For example, one might be able to use the golden monitor to say something about air quality in Banff, for instance. So nonetheless, based on that, and also considering that the far north and far south frequently get wildfire smoke, we sort of adjusted the analysis and grouped them into higher priority and lower priority. And we also wanted to work with communities that specifically requested monitoring. So this is great. We've got an idea of where the smoke occurs and sort of which communities from a scientific point of view should be prioritized for receiving air monitoring. But then the million-dollar question is, how do you actually fill these gaps? So as Krista alluded to, we use this technology called Purple Air, or PA2s. So we're not super innovative here in the sense that lots of other jurisdictions also use Purple Airs to monitor particulate matter and for wildfire smoke. But these are great because they're low cost. They only cost about $300 Canadian. They're easy to use, they're reliable, and they report data in near real time. They've got built-in Wi-Fi and minimal power requirements. You just kind of plug them in to the to a wall socket and then you're good to go. So here is a series of Purple Airs set up for testing outside our Edmonton McIntyre shop. So what I'm going to do now is actually just stop sharing so I can show you what a Purple Air actually looks like. So just confirm that you can see me on the video instead of the screen, and I can walk you through the components of the Purple Air.
Yeah.
Perfect. Thanks, Krista. Thanks, Marilee. So yeah, this is what a Purple Air looks like. It's about the size of an orange, a little less tasty though. So it's got this metal bracket here that you can attach to the side of a wall or a fence post or just a wooden stake in the ground. And it's got this cover on top, so rain and debris don't get in it as easily. And then if I flip it over on the bottom, here's where the actual sensors are. So the way it works is it's got two identical channels, or what we call channels or sensors. And there's a fan in here that will suck air in. And inside, each of these blue rectangles or compartments is a laser. And the laser will count or reflect light off of any particle that passes across its beam. And if the laser light is reflected, it's picked up by a detector. And the way the detector picks up the signal, it can figure out sort of the number of total particles, as well as the approximate size of the particles. So then what the software in the Purple Air does is it converts that size and count number into a concentration, so micrograms per meter cubed. But to do that, it has to assume something about shape and density as well. And the reason there are two channels is if one goes kaput, then you still have another good measurement. And if both are working, then it can give a good indication or sanity check that you're getting good data. Because if both channels agree, then chances are the Purple Air is still working pretty well. So that's why they include two channels. Yeah, and then it comes with a power cord as well. It can plug in, and the installation takes maybe 10 or 15 minutes. So yeah, it's a really useful tool that can be used to monitor particulate matter. So, the next question that you're probably wondering, well, it only costs $300 and you get what you pay for, right? And it's a lot cheaper than a $300,000 traditional air monitoring station. So how well does it work? So we're not the only ones that have, been answering this question. It's been done by a lot of different jurisdictions around the world, but work led by Zheng Yang on our team has looked at how well it performs in an Alberta environment. Because not everywhere in the world gets to be -40 in the winter and plus 35 in the summer. So what's shown here is what Zhang did is he took a Purple Air and he put it right beside two different other instruments that provide a more precise and accurate measure of particulate matter, and then plotted the data. So each blue dot here is just a different, I think, 1 hour time measurement. So on the left is comparison against the Teledyne T640. So this is one of the methods you'd find in a traditional air monitoring station. So it's compliant with the air monitoring directive. It's used by a lot of airshed organizations to measure PM 2.5. And then on the right is a comparison against the EBAM, which is that sort of tripod portable particulate matter monitor that I showed you that we use for emergency response monitoring. So in both cases, the fit is pretty decent. These data have had a correction factor applied to them because purple airs are affected by relative humidity and temperature. So in order to get around or to minimize the effects of relative humidity on the readings the purple air gives, you can come up with this correction factor that can be applied. So Zhang did that. And you can see there's, almost a slope of 1 and a really good R-squared value in both cases. And just notice that both figures have different scales. So, concentrations below 70 on the left, and then the EBAM was actually deployed for wildfire smoke monitoring purposes. You get these much higher concentrations, but suffice it to say, the purple air 2 works well enough to monitor wildfire smoke. We're not using it to monitor for regulatory purposes or compliance or anything like that, but it works well for monitoring wildfire smoke. So hopefully I've sort of set the stage for you to show you how citizen science can really help and I think is necessary to fill these gaps in rural and remote environments. Again, because it's not feasible to deploy some of the more sophisticated monitoring in each and every community in Alberta. So what our air monitoring team did is they reached out directly to communities that we identified as a higher priority or that we had existing partnerships with, and just gave them a call and explained the program and gauged their interest. So yeah, the air monitoring team that did that was led by Marty Collins, and Farron, Bibby, Laura Tabor, and Ramneek were the ones actually calling and liaising with communities. And then Krista and her team from Community-Based Monitoring and Knowledge also contacted various Indigenous communities in Alberta that we have existing partnerships or relationships with. And yeah, spoiler, some of the communities are interested. So here you can see a Purple Air 2 deployed outside at the town hall in High Level. Here's the one deployed outside the town hall in Wainwright. So the way this actually worked is we call the communities, and if they're interested, then Marty and his team would ship them a sensor. So we didn't actually go and deploy it. The communities have to deploy it themselves. And we'd give them an installation guide, which we developed in collaboration with Environment Canada, because they have a similar program. So we leveraged some of their learnings. So it's just step-by-step instructions on how to connect, register, and deploy the Purple Airs. And we also included a Purple Air fact sheet, which we developed, again, with input from Environment Canada and Alberta Health, which just summarizes the basic facts and how to interpret the data. And this is, of course, publicly available online. Perhaps the most useful tool, though, are the websites that display Purple Air data in near real time. So there's 2 of them. I'll show you this one first. This is the Purple Air website itself. So as long as the Purple Air is connected to Wi-Fi, you can actually look it up and it'll appear on this map, which is run by Purple Air, the manufacturers of Purple Air. And it shows you all the Purple Airs registered in the world. So since there are a lot of people from Edmonton, including myself, I'll just kind of zoom in on Edmonton and quickly demo some of the features. So right now it's showing raw PM 2.5 10-minute data. The sensor is gray, that means it's offline. And you can also toggle here, there's different features you can bring up, like, temperature, relative humidity. You can also adjust the scale to report various air quality indices. It says Canadian AQHI, but that's not a true measure of AQHI because these sensors only measure PM and do not measure NO2 and ozone, so take it with a grain of salt. But yeah, you can see there's lots of Purple Airs deployed in Edmonton already by various organizations. Like this one at the Edmonton Macaulay Station is operated by, or was put in place by us, EPA, the Alberta Airshed Council, the ACA. So they're the airshed organization in the Edmonton and surrounding region. They've been really great in proactively deploying these Purple Air sensors. So most of them in the Edmonton region are actually from the ACA. You can see Environment Canada also out of the Edmonton regional office hands out a lot of Purple Airs, so they deploy them first. So here's the Environment Canada offices and them testing about 20 Purple Airs. But then I know there's even private citizens that will deploy Purple Airs. Like this one here, my friend's a chemistry prof studying air quality stuff at the University of Alberta. So here's the air quality sensor he bought and just put outside his home. So So yeah, a map like this is great because it takes purple airs from all the different organizations that have deployed them. So the second map is this map that's been developed by Environment Canada in collaboration with the University of Northern British Columbia. So it's very similar to the purple air map, but there's a couple key differences which I'll highlight. So one is you'll also notice these diamonds here. So this map also shows in Alberta and BC and Saskatchewan some of the permanent air monitoring stations, which can be handy if you're trying to get a more holistic view of air quality. This map also provides a correction factor, so the data could be considered more reliable off of this website, because again, there's that correction factor that accounts for the effects of relative humidity and temperature. So yeah, I definitely encourage you checking out these websites. We look at them frequently during wildfire season on our team just to get an idea of the spatial scale of where the smoke is at. It can also be used to help to ground truth some of the models like blue sky that are used. So I just want to say a few words on coordinating deployment, because as you can see, there's a lot of purple airs deployed throughout Alberta. So I've just taken a screenshot here of the UNBC map, and I put stars around the ones that our team has proactively deployed for wildfire smoke monitoring. We've also deployed several for focus studies, which are kind of short-term studies aimed at better understanding like very specific local air quality issues. But of course, there's dozens of other purple airs that have been deployed by Environment Canada, airshed organizations, private citizens. So we attempt to touch base with our counterparts at the federal government and also airshed organizations to keep an open line of communication to make sure that we're not aiming to put 3 sensors in the same community, so that we're maximizing efficiency and using our resources to the best of our ability, but also to make sure that our messaging is consistent, because we'd be doing a disservice to the public if us, the federal government, and airshed organizations were all saying different things on how to interpret the purple air data and sort of what the uses are. So this project's been really great because it's really allowed us to broaden our horizons and form great working relationships with external organizations. I'll also give a shout out to the Northwest Territories, our neighbors to the north. So I saw this CBC article posted last fall. So the government of Northwest Territories is doing something similar. It's not specific to smoke monitoring, but working with Environment Canada, they're aiming to get a purple air sensor in every single community in the Northwest Territories, which is, I think, a total of 35 communities. So they're actively soliciting community volunteers to host sensors. So yeah, I mean, I don't want to give the impression that we're the only ones doing this. Just a couple more slides. We a year and a half ago wanted to evaluate where the project was at, so we did 2 different surveys. The first one was an online survey that we conducted in collaboration with our counterparts at Engagement and Education. So I was targeting more the data users of purple air trees, so the air quality experts and practitioners. But then Marty and his team from air monitoring also called communities that hosted the purple airs just to see how it was working for them and if they had any suggestions for improvement. So there are just some example questions we asked. I won't go through all 30 questions and what the responses were. Just summarize them here in a few bullet points. So for the online survey, we had 35 responses, primarily public sector employees. People thought that the data maps were well used, so the UNBC and purple air maps that I showed you. Some suggested improvements that kept coming up in the responses, more coordination for the dissemination of data and info to communities, creating auto alerts and providing support on data analysis. And I think these are all very important points, but I don't think they're necessarily specific to monitoring for wildfire smoke. I think it's sort of a bigger picture. How can we improve utilizing purple airs? And then for the phone survey, 6 communities participated, and Barty and his team found that they thought the support from Alberta Environment and Protected Areas was sufficient and that they found the data useful. And I think the best part was they actually shared the data with others. Because at the end of the day, if we put all the air monitoring out in the world, it doesn't do any good if it doesn't help the public make informed decisions about protecting their health. So just to wrap up, hopefully I've convinced you that wildfire smoke is a significant and increasing air quality issue, and that the traditional air monitoring network that we have is very robust and comprehensive, but there were gaps with respect to smoke monitoring, and these gaps are being filled through these new low-cost sensors and through citizen science. And then the next steps, we're going to continue to deploy additional sensors. I think we've got 6 ready to go, so we'll have conversations next week with Environment Canada and Alberta Health and a few others to figure out how to best use these. We are now performing weekly checks on the sensors we've deployed for smoke monitoring to see if they're faulty or broken, and if they are, we contact the communities right away to troubleshoot. We also want to work on making sure the data are reaching the public in the right hands, so that the data are utilized effectively, and also raising awareness, which I guess this presentation is sort of ticking that box. So again, I appreciate the community of practice allowing us to present this. And I'm looking forward to the discussion afterwards. So yeah, if you have any questions, I'm happy to discuss or try and answer them. And if anything pops up afterwards, feel free to send me an email or drop me a line.
Great. Thank you so much, Greg.
Yeah, my pleasure.
Deeply deep gratitude to you for the time that it took to put together that great presentation, to spending an hour and a bit with us today. Loved your attempt at art at the beginning.
Thanks. I should have gotten my kids to draw it. They would have done a better job.
There you go. Yeah, that was great to get a mini science lesson, and fantastic to see some of the links you shared. And thanks, Caitlin. If you're not paying attention to the chat box, Caitlin has compiled all of the links that Greg shared in his presentation for your interest. So we do have quite a few questions, Greg, that came through the chat. And so I think some maybe you may be able to answer quicker than others, perhaps. And then I think if we get through those, because we have about 20 minutes or so, then if there's others on the line, you're more than welcome to unmute and ask your question, or put it in the chat, or raise your hand. There's multiple options here. So maybe some of the easier, quicker questions here, Greg, are: is there an app for the AQHI? I'm just going to go actually in sequence of as the questions were asked. So is there an app for AQHI?
Yes, there is. Amy Ty from our group would be the best person to answer that, because she's been heavily involved, but it recently migrated over to the WeatherCan app. So that's that app was developed by Environment and Climate Change Canada. So if you Google WeatherCan app, it should show up. So that gives weather information, but it also gives air quality information. So there's an app, you can register for that, and I believe you'll get special air quality statements as they're issued, or special air quality statement alerts on the app. And Amy, if you have anything to add, please feel free to type it into the chat. I'm not sure if Amy's on, but or anyone else from Airshed Sciences team.
Great, thanks, Greg. Yeah, Amy, if you're still here and you want to add anything, either to the chat or unmute yourself, you're welcome to do that. The second question was, would you be able to share your presentation? And I think I've been getting some messages on the side here. It's hard to pay attention to multiple things. But yeah, is that something that would be okay? We could distribute it to participants afterwards.
For sure, yeah, I'm happy for it to be shared. I see Marilee and Bob are on the line, so if that's not okay, then Marilee and Bob, please indicate so. But I'm all for open communication and sharing knowledge. Oh, I see Marilee. Thumbs up. Perfect. Thanks, Marilee.
Great. Excellent. Okay. Now the next question was from, oh my goodness. It was, sorry, I'm just from Hal. And Hal, I don't know if you want me to ask it, or if you want to maybe come off mute and ask it yourself. It was the one about the threshold of PM 2.5. Maybe you're shy, so I'll ask it. I feel like I'm on a radio show. So the BC CDC has a lower threshold for when PM 2.5 drives a high AQHI, so 60 micrograms per meters cubed, versus Alberta's 80 micrograms. Are there any plans that you know of to lower the threshold in Alberta to 60 micrograms per meter cubed?
That would be more a question for air policy. I know that through the National Air Quality Management System, we're always striving for continuous improvement. You know, thresholds over time have been getting lower and more stringent, and that drives better air quality management actions and responses. So I think those conversations are live. I can't recall off the top of my head because I'm not directly involved in the work if they're live right now for PM 2.5, but I know there are ongoing discussions about revising the provincial objectives and guidelines for things like nitrogen dioxide. So yeah, sorry that was only kind of a partial answer. Again, others on the line, feel free to chime in if you have more information than I do at this time.
I'll just maybe give a moment to see if anyone wants to chime in. So thanks, Greg. There's actually, I think, a couple of questions from Nikki. The first one is, actually, Nikki, if you're there, would you be okay asking this question? Because I'm not sure which stations you were referring to. Are you still here, Nikki?
Yeah, here. Hear me.
Yes.
Hey, Greg, we had a quick conversation about kind of the whole greenhouse gas emissions part of peatland, just peatland disturbance through wildfire and climate change and harvesting. But I was wondering if these units, so since industry is was part of that pie chart you had, not pie chart, but was a industry or a topic that was monitoring for air quality. It's regulated. And that's for, I'm assuming that's for like their equipment, right? Monitoring like mass amounts of equipment that's working there, possibly around the clock.
Yeah, or anything that could emit stuff to the air, you know, like from a mining fleet or a smokestack, for instance.
Right. So I was wondering if something like that do you think some of those instruments or something that's modified, would that work for an area that has maybe a more concentrated, like a concentrated area where there might be peat bog degradation maybe? Because those are both for like industry wise, like if oil and gas and coal mining have regulations, would this type of equipment also work for something that's not quite as maybe pronounced? Yeah, I'm wondering if those instruments would work or if that would need some other sort of technology.
So for regulatory compliance, I think you'd need some sort of other technology because the specific number does matter if there are regulatory implications. But I think if one wanted to get a sense of the general levels, or we're using it as sort of part of an air quality management strategy around a facility, there may be a piece that Purple Arrows could play there. With respect to peat bog mining, if they're kicking up a bunch of dust, then the Purple Air sensors would certainly be able to pick that up if you're close enough, or you're digging up enough dust, or as they're drying the peat out, you might get some wind blown emissions if it's really windy. So yeah, there's a potential, but I think using it for regulatory compliance, the technology isn't there yet.
Okay, more for like maybe just kind of like baseline monitoring, just to get an idea.
Yeah, it could be useful for baseline monitoring.
Awesome, thanks.
Great, thanks, Nikki.
Thanks, Nikki.
Greg, at the end of your presentation, you talked about having worked with some communities last year. There's a question here, how could one get involved with setting up a Purple Air unit in their community? Is it as simple as reaching out to you?
It could be. So there's The good news is there's lots of ways to get involved. So I think for this smoke project that I talked about, I mean, I think we've got 6 or 7 spare sensors. I think Marty and his team are going to order more. So if you're in like a rural remote community that dovetails or, you know, doesn't have any nearby air monitoring, I think that would be a good fit. I know Environment and Climate Change Canada, they've got a whole ton of sensors. I mean, I showed you about 20 or 30 of them on the map. They at one point had, you know, over 100. You know, I think they can give them out upon request, although I'm not exactly sure how they prioritize that, or so I can put you in touch with our counterparts at Environment Canada. Airshed organizations, if you live within an airshed organization boundary, that could be another way if they have sensors they're interested in deploying, or you just want to learn more about air quality, definitely reach out to an airshed organization, or you can just go buy one, or you know, ask for one for Christmas or something. Like my colleague at U of A, they're only $300, so he bought one. I realize $300 is a lot, and that is quite a barrier. But yeah, I mean, those are the different ways you could get involved and get one for yourself. I thought about buying one for myself too, but I can just get one from Marty, I guess, or borrow it for a presentation. Borrow it.
There you go. There you go. There's a few more questions, but I just want to, because there are a number, I think, of airshed organizations on the line today. Just want to invite anyone who is here to share if you do have a purple air monitor, or if this is something that you might consider in your airshed region.
Yeah, I see Lorna Morishita from Palace Airshed Society. Yeah.
Okay. Yeah,
Go ahead,
Lorna,
Lorna.
please.
She commented in the chat, but
yeah.
Hey, it's Lorna from Palliser Airshed. We got a number, like you guys said, from AEPA. Also, we got one from Marty that went in Brooks. So we have 14 right now. We got Alberta Parks to put one in at Cypress Hills Provincial Park, and we just started calling communities kind of bigger than 500, and then 500 people, and then we also tried to make sure we had one in every municipal district. So even Acadia Valley has one, and they're teeny tiny. And we'll add probably 7 more this year. But if you want one for any of your communities, give us a call. I might have tapped out AEPA, but we can see what we can do to purchase some more too. If it's, you know, we'll see how it fits into our network in the community, but you can see our network map online, and it mostly says PAS in front of our sensors that we got from AEPA or the ones we got ourselves. So it's pretty good, what we call the complementary monitoring idea. We love them.
Great. Thanks, Lorna, for sharing that. Any other, it's been a while since I worked with airshed, so I don't recognize names as much as I used to. Anyone else want to share if you have deployed these or are interested?
yeah, I don't see anyone else from any airsheds
Okay.
on the list.
Okay. Greg, this is an interesting question. Is there any work being done on indoor air quality during smoke events? And maybe to add to that question, is purple air something that you could deploy inside in addition to outside?
Yeah, so I'll answer the second question first because it's easier. Yes, you can deploy them indoors. And I think when you set it up, there's even a box you can tick indoor versus outdoor. So it's indoor. I don't think it appears on the map. Or if it does, there's, you know, an explanation that it's indoor. Yeah, indoor air quality is tricky because every space is so different and heterogeneous, and there's a lot more going on. It's a very different environment than the outdoor. In terms of smoke impacts inside versus outside, if you keep your windows closed and have like a filter on your furnace, it's going to be better inside. Air quality, that is. But more generally, when it's not a smoke event, air quality can typically be better outside. So if it's not -30, you know, opening your windows can help with indoor air quality. But it's really hard to study indoor air quality again because there's so many differences from room to room. So it's hard to generalize. But yeah, I mean, if you're curious, you could set up a purple air inside your own home and, you know, see what it does during a smoke event. And there are people studying indoor air quality, but that's not within the purview of our group. I mean, we're ambient or, you know, outside air monitoring. But in the research community of atmospheric chemistry, it is a pretty hot topic these days. So a lot more people are looking at indoor air quality now than I think they were 5 years ago.
Interesting. Thanks, Greg.
Okay.
There's a question here from Brian Free. Wind direction and speed is likely very important regarding wildfire smoke. Are wind monitors co-located, or do purple air monitors collect that data?
That's a great question, Brian. So you're absolutely right. Wind direction and speed has a profound impact on air quality. So no, purple airs do not measure wind speed or wind direction. But the continuous air monitoring stations that I showed you, they all measure wind speed and wind direction very accurately and report it in near real time. So if you're looking sort of for a regional perspective, which is, often most relevant for a regional event like smoke, looking at the wind speed and direction at a nearby station, even tens of kilometers away may suffice. And of course, there's weather forecasts, right? So the blue sky model, like it incorporates weather forecasts that has wind speed and direction modeled at all layers of the atmosphere at varying spatial scales, is used to model smoke. So short answer, no, purple airs don't monitor winds, but for looking at and predicting smoke impacts, something several kilometers away should suffice.
Mm-hmm. Great. Okay, I'll keep moving down the list. Is there collaboration with the US as there is with BC? So for example, Montana or California?
That's a good question. Not to my knowledge, at least not at sort of the level that we're talking about deploying purple airs. I guess that being said, the border between Alberta and the US is pretty small, so it might be more relevant in places like Ontario, where Detroit is right there, and you have a lot more emissions. But I know at the national or international level, there are air quality agreements between the US and Canada, but I only know about them because of my former life when I was in Environment Canada. But short answer for something like this, no, not to my knowledge, but there are international agreements that exist for transboundary pollution.
Great. Okay. This question's from Bradley, one of our steering committee members. Is blue sky smoke available as a real-time tool for current predictive wildfire smoke, or is there a tool you can recommend?
So blue sky forecasts, I believe, are twice a day, and there are good for a couple of days forecasters. I think 2 days forecast. So that can give you an idea, like a spatial idea. I think you can actually play the map and it sort of forecasts hour by hour of where smoke is currently, and then where it's going to go based on the size of the fire and weather forecasts, which includes wind speed, direction, temperature, rain, that sort of thing. So I mean, that's the tool I would recommend. There's also another one, I think it's called Fire Smoke. I can't remember off the top of my head, but there's also a national forecast tool that the Environment and Climate Change Canada uses.
Okay. Maybe that's something that if you recall, and we can share that information out later.
Yeah, you can be an action item for that. Or
there
anyone from Airshed Sciences, please feel free to chime in, because I know some of you know the answer.
Absolutely.
I'll phone a friend.
So this is a question that I don't think has come up yet from Iris. Other than referring partners to the UNBC and Purple Air maps, are there other things being done to communicate results?
So results of wildfire smoke, I think I covered them in this presentation, but air quality in Alberta, there are a couple of others, and some others on the line. Maybe you could put the link in for Iris and others, but there's the Condition of Environment website that is put on through the Office of the Chief Scientist in the Government of Alberta. So there's an air quality section there that contains trends and information about PM 2.5, NO2, and ozone. And again, this isn't specific to smoke, although I think there is a small section in there about smoke. And that website also has other indicators, some of which are still in development, but I know they have climate indicators already, and I think there might be some water indicators, and Marilee is also very familiar with this work. Then there's also the annual status of air quality or status of air zones report that's released annually. So that's reports against the Canadian Ambient Air Quality Standards, which are federal standards and our level of achievement. And that's combined now with the Air Quality Management Framework reporting that's done or mandated through the Lower Athabasca Regional Plan and the South Saskatchewan Regional Plan. So they're definitely a little more technical. The COE is actually at a pretty high level, so it's intended for the general public or an informed audience. But the status of air quality report, it's pretty technical. Yeah, there we go. Cassie and Amy got us covered. And
excellent.
Yeah, thanks.
See, team effort all around.
It was teamwork. Yeah.
Yeah, there you go. Awesome. Okay, so we've got about five more minutes for questions, and it's hard because there's a lot of good questions and comments that people have made, and I think some of them have been answered in the chat. So, for example, Greg, there was one about using Purple Air offline, and I think someone had mentioned, oh, now it's gone. Someone said my organization purchased Purple Air Classics that don't need Wi-Fi. We'll be using them this summer, but I guess that doesn't answer the question about using them off grid. I wonder if you could speak to that, because in your presentation, it seemed that you need to plug these units in order for them to be functional.
Yeah, so they need power, but they don't need Wi-Fi to work. The Wi-Fi is just so it can appear on the map and you can get the data in near real time. There are models available that just have an SD card, which fills up after a while. But if you don't need the data in real time, just want to deploy it somewhere sort of more off grid, just get an SD card version or model of the Purple Air, and then put it out for however long you want them, and you retrieve it. You just download the data off the SD card.
Right.
Yeah. And yeah, I don't know. I don't have a good sense of the power requirements and what that would mean for batteries, but maybe you could get a large enough battery pack and that would keep it going for some amount of time.
Right.
But I'm definitely an engineer. Oh, and I just see, sorry, Carla Reeser from the Pramp Airshed. She's also online, and the Pramp Airshed also has several Purple Air monitors. So if you're in the Peace River area, then please contact Carla at prampairshed.ca. Thanks, Carla. And sorry, I missed you in the list. Yeah,
I did too. I know that name. Nice to see your name here, Carla. Okay, so let's just going down to the very bottom just to see. So we'll go with, there's another question here from Hal. He says, we are switching to the UNBC map page instead of the Purple Air map page. We understand that the UNBC map page may do a better correction. Can you comment?
Yeah, so to my knowledge, the Purple Air doesn't do a correction. It's the raw data. And I mean, it's been shown by multiple organizations, including our own, that there's temperature and relative humidity dependence on the Purple Air data. So for example, if you have the same level of PM 2.5 over a period of time, but the relative humidity is changing, then the number that is reported by the Purple Air is going to change. And the way it changes is different from location to location because it depends on the size of the particle and what it's made of. So I guess more site specific the correction factor is, the better. And I know the UNBC and Environment Canada has done a lot of work on a correction factor. So for those purposes, and also because of the fact it shows some of the continuous air monitoring stations on the map, we actually typically, I think in the fact sheet, directs people to the UNBC website. And I believe it's also easier to download historical data off of the UNBC website, although Zhang would know best. He could comment on that directly. So yeah, I mean, that would be my comment. I think both are useful, and sometimes one site goes down or isn't working. So it's nice to have multiple sources, but yeah, I think we typically refer people to the UNBC website. And certainly on a personal level, I use the UNBC website as well.
Great. Okay, thank you. And I know I just want to acknowledge there were lots of other great comments and potentially more questions in the chat that we weren't able to get to today. But yeah, it's always amazing the level of engagement of the community of practice. So thank you, everybody. So Steph, can I turn it over to you to close us off?
Yeah, absolutely.
Okay.
Thank you. Thank you so much, Greg. And again, everyone, for all of your engagement. I certainly learned a great deal about air quality and monitoring today. And I'm almost interested to get an indoor monitor for my house and an outdoor one. Then I know when it's best to open the windows and have the best air quality possible. So that's certainly very interesting. So April is Citizen Science Month, and with spring upon us, it means many of the naturalist-led citizen science BioBlitz and projects are kicking into gear. So I wanted to let everyone know a few important dates so you can get involved wherever you are in the province. So we have the City Nature Challenge coming up April 28th to May 1st, where you can contribute nature observations through iNaturalist by taking pictures of whatever species you're seeing outside in the city and adding them on iNaturalist. Our big May species count, which includes bird counts as well as plant counts, is generally the last weekend in May, but it varies by the count circle. You can visit Nature Alberta's Citizen Science webpage to find links to all of the different events and projects listed here to connect with those events and find out more information about participating. The Alberta Biodiversity Challenge is happening this year from June 8th to June 11th. This originally started as the Biodiversity Challenge in Edmonton, started 3 or 4 years ago, and it has now expanded to include all of rural Alberta. And this year we're also compiling results from Alberta parks, which I'm really excited about as well. On Nature Alberta's Citizen Science webpage, we have an extensive list of ongoing projects organized by different species. So for example, you'll see a list of bird projects, mammal projects like the Franklin's Ground Squirrel Project, which Nature Alberta initiated to help fill the data deficient gap to assess the squirrel's population for conservation considerations. We have insect projects such as the Bumblebee Watch, a couple different amphibian and reptile projects, plant and fungi projects, biodiversity projects, and also aquatic projects like the Summer Lake Keepers. If you have a project that you would like to have added to this list on this webpage to help promote it, you can send me an email at info@naturealberta.ca and we can promote that through this list as well as on our social media platform to 16,000 followers. Yeah, Caitlin, you can go to the next one now. So I'm excited to say that the Citizen Science Steering Committee is working towards developing a collaboration hub. Many of you have already contributed to this. To beta test the hub, we are planning an in-person conference meeting for this time next year, along with other opportunities such as presenters and workshops. So we'll be looking for your input to make it the most amazing and valuable conference possible.